Okay, this is the third and final of our Hoverpuck simulations, and it brings in a critical concept that we'll have to deal with if we're going to thoroughly describe the motion of objects. And that is that things don't always move in the same direction. In our first two races, all the pucks were moving toward the same finish line. But motion doesn't all have to be toward the same point. Things can move in different directions. Now, to deal with that, we're going to have to understand the concept of a vector versus a scalar. In this case, we're going to look at a red puck and the black puck again, but they're going to be moving in different directions. Now, the time again is going to show up here. Again, we're going to get the same tracks that we got last time, every certain amount of time. This case, there is no finish line. We're just going to let them go until the simulation stops. So away we go. Here they go in their motion. Okay, and there they are finished. Now, in the tracking pictures, you'll see there's no real way to tell after you're done what direction the objects are moving. The black puck could be moving to the right or could be moving to the left. If you don't know your initial position over here, you really can't tell what direction you're moving. So we're going to need to know where we start things as we look at their motion, and then we're going to want to know where they finish. Now, this is time 0 and this is time 0. So these two way over here are actually the ones that go together. This is the next tracking time, so these two go together, and then these two, and then these two, and so forth down the line. So it's a little more difficult to compare using the tracks in this case. Now, here's the graph of the two motion. Here's our red puck and here's our black puck. You should notice something very different about the black puck's motion in terms of the direction the graph is heading. We're going to have to be able to deal with this the idea of direction both visually and graphically as well. So knowing the difference between the red upward and black downward motion is going to be an important part of what we do as well. So again, you'll want to pause the simulation and answer these questions about the tracks of the Hoverpucks, and then answer the blue questions about the graph of the Hoverpuck motions. Again, similarities, differences. What happens when the two lines cross? What could, if I understood the language of motion, if I looked at this graph, what could I tell you about it without having to see the actual race itself? In the end, that's what we're kind of heading toward, is can you look at tracks of motion or graphs of motion and be able to describe what happened in the past? Not only would that be helpful to be able to tell us what happened in the past, it might be helpful in letting us determine what's going to happen in the future. So go ahead and pause, answer those questions, and this is the third and final of the Hoverpuck simulations.